In school, we are expected to take in and think about many new concepts, procedures, facts, and ideas in a short period of time. This leads to a common problem, being overwhelmed by too much new information. For example, in a lecture, the instructor delves into a new topic, and in a few minutes we're lost. Or during a class discussion, students keep jumping from topic to topic. We lose the thread of the discussion and have only a jumble of ideas in our heads. Why do we become overwhelmed? Is it because the instructor goes through the material too quickly? Does the lack of organization make it difficult to keep track of the ideas? What about the complexity of the topic? When a new idea is complex, we often have to slow down and think carefully and go back over the material. Other times, when we're talking about a very familiar topic, the discussion can be very disorganized, but we can still understand it. What's going on? How can we understand overload? And what can educators do to reduce it so that students learn more effectively? To understand why we become overloaded by new information, we need to examine two key ideas: working memory and cognitive load. In a previous video, I described working memory as the mental capacity involved in conscious thinking. Whenever we take in new information, mull it over, and think about it, that takes place in our working memory. Working memory is the mental space where we do our conscious thinking. Unfortunately, working memory has a very limited capacity. We can only manipulate or think about a few pieces of information at one time. So, if we're inundated with a lot of new information quickly, there's a good chance we simply can't process it. By the time we can attend to it, it may already be forgotten. This means that working memory is a kind of bottleneck in learning. We need to actively process information in working memory in order to get it into long-term memory. The problem is, we can process only a limited amount at any given time. Cognitive psychologists refer to situations in which we are overwhelmed by information as involving excessive cognitive load. Cognitive load is the amount of mental resources needed to accomplish a task. When we are overloaded, it simply means that the demands of a task exceed our working memory capacity. We get bogged down and learn less. To illustrate, if I ask you to multiply two one-digit numbers together, you could probably do this easily in your head. The cognitive load would be relatively light. And if I ask you to multiply two three-digit numbers together, you could probably do this easily as well, if you could work out the answers on a piece of paper. Again, no major problem with cognitive load. But what if you had to do the calculations mentally, without access to paper and pencil? Try it. It's quite difficult to keep track of the rows and columns in your head. The cognitive load of the task exceeds your working memory capacity. And note that even a relatively simple procedure like multiplication can tax our working memory. So, as humans, we're stuck with puny working memories. What can we do about it? We cannot really increase the capacity of working memory, but there are ways to make better use of the capacities we have. To explain this, we need to examine the concept of cognitive load more closely. Researchers have shown that in any learning situation, there are three sources of cognitive load, and teachers can reduce and manage load if they look carefully at how they design and present tasks to students. This is the table from page 239 of your textbook. I will use it to walk through the different types of cognitive load. First, intrinsic load is the basic mental processing we need to attend to and initially think about the task or material at hand. For example, to multiply two numbers together, you need to start thinking about what the actual numbers are, what the arithmetic procedure is, the actual sequence of steps, and so forth, so that you can start to work out the answer. This is a kind of basic processing intrinsic to doing multiplication. Second, extraneous load consists of mental processing that is actually irrelevant to the task. Let's say the teacher is teaching students how to multiply two numbers, but is doing it in a very disorganized way and interjecting irrelevant information into the lesson. The instructor has added extraneous load to the situation, making it harder rather than easier to carry out the task. So sometimes Poor instruction produces excessive extraneous load and makes learning harder. Finally, there is germane load, which is a deeper kind of processing, such as integrating new information with prior knowledge, that is likely to result in better understanding on the part of the student. As teachers, we want students to engage in this type of processing, but it does make learning more complex. For example, if I am learning how to multiply fractions, I could simply follow the rule and carry out the procedure in a rote fashion. Multiply the numerators, multiply the denominators, and then reduce the fraction if possible. In other words, I could learn to multiply fractions without really understanding what I was doing mathematically. But if I was thinking hard about multiplying fractions, thinking about it mathematically and trying to understand it, I could realize, for example, that multiplying fractions looks different than multiplying whole numbers. For instance, 2 times 2 equals 4. When I multiply two whole numbers together, the product is a larger number than the whole numbers. But when I multiply 1/2 by 1/2, I get 1/4. The product is actually smaller than the original numbers. This might lead me to think about how multiplying 1/2 by 1/2 is really like taking 1/2 of 1/2. And of course, when you take 1/2 of a half, you end up with 1/4. Okay, so you see that germane processing involves more effortful and complex thinking about the material. I have tried to connect the new information to things I already know about multiplication. To summarize briefly, our working memories have limited capacity, which means that we can only think about a few pieces of information at one time. In any learning situation, there are 3 sources of cognitive load making demands on our thinking. Intrinsic load is the processing we do to engage in basic learning. Extraneous load is the extra processing we need to do because of the way the material is presented and taught. Poor instruction adds a lot of extraneous load. And germane load involves deeper cognitive processing needed to understand the subject matter. Germane load makes tasks more difficult, but the payoff is greater because students tend to develop deeper understanding of the subject. In the last part of this video, we examine how teachers can manage and reduce the cognitive load associated with their lectures, assignments, and activities. I want to introduce 5 general strategies for reducing and managing load. I won't go into great detail about each one, but we will return to these ideas during the course because they are important strategies for teaching.